we need to find the general solution of z into xp minus yq equal to y square minus x square. So we have to write the Lagrange subsidiary equations first. The Lagrange subsidiary equations, and the equations are dx divided by capital P equal to dy divided by capital Q equal to dz divided by capital R. The format of the equation is capital P into P plus capital Q into Q equals to R. For this format, what is the capital P? It is z into x, right, from this equation, and capital Q is minus zy, right, and capital R is y square minus x square. Is it okay? Fine. So writing this, so this implies we have dx divided by zx equal to dy divided by minus zy equal to dz divided by y square minus x square. From these two we get dx divided by zx equal to dy divided by minus zy. We can write this as, we can cancel z from both the sides. Dx divided by x plus dy divided by y equal to 0. And now integrating this. So on integration, we get the integration dx divided by x plus the integration dy divided by y equal to the integration for 0. Integration of 0 is a constant, right? So this implies, okay, integrating x with respect to x, we get this to be log x plus this is log y, and let me write the constant to be log of c1. So this implies log of xy equals to log of c1. That implies xy is equal to c1. So this is the first solution we have got from the auxiliary equations. And now to obtain the second solution, for that, if I use the multipliers x and here y and here z, so in the denominator what I get, it is zx square, and here I am having minus zy square, and here z into y square minus x square. If I add all these denominators, what I get, zx square will be cancelled out with this, and minus zy square will be cancelled out with this, right? So I am getting 0, right? So let's add these. So using the multipliers x, y, z, we get x dx plus y dy plus z dz to be equal to 0. And what we get on integration, it is x square plus y square plus z square equal to, let me take the constant to be c2 here. So this is another solution we have got from the auxiliary equations or the Lagrange subsidiary equations. So hence the general solution of the given equation is, what is the way to write the general solution? It is f c1 c2 to be equal to 0. This is the first solution and this is the second solution. So writing here, f, what is c1? It is xy, comma, what is c2? It is x square plus y square plus z square and is equal to 0, where f is the arbitrary function. F is the arbitrary function. Alright, thank you.